Welcome to you for this NPTEL online course on earthquake resistant design of foundations. Myself is Dr. BK Maheshwari. I am a professor at Department of Earthquake Engineering, IIT Roorkee. My email is given on this slide. Let us first discuss that what is this importance of this course. You know, our country India is seismically very active. We have very frequent earthquakes, particularly in Himalayan regions, and safety of foundations is very important during earthquakes, and this course is being offered first time, which deals with earthquake resistant design of foundations, and this course will go long way for those working with foundations and need to account for earthquake loads. The course will teach the students, academicians and practicing engineers the design of foundations, so that these are safe during earthquakes. You could see that this is the map of our country showing seismic zones of India. The country has been divided in 4 zones, 2nd, 4th and 5th. There is no zone 1st as because the zone 1st has been merged with zone 2nd. So, you could see from this map clearly that whole of the Himalayan region lies either in zone 4 and zone 5. The Uttarakhand state, where the Roorkee is situated, is also lying in zone 4 and zone 5, and even in, if you see Gujarat, and so there are zone 4, 5 and zone 3rd also. All of the Andaman and Nicobar islands are lying in zone 5. So, there is no doubt about it that country is seismically very active, and we need to take care of earthquake loads while designing of the foundation, and that is the prime objective of this course. As for the target audience are concerned, this is basically a PG course. However, this may be also offered to final year UG students of civil engineering. Soil mechanics and foundation engineering is a prerequisite for this course. However, because this is also being offered to the practicing engineers who have left their studies long back, therefore, this course, in this course some basics will also be discussed related to foundation engineering. Let us briefly discuss what are the course contents. The course will cover various types of foundations, required soil investigations, soil parameters and course of practice, design considerations for seismic resistant design of foundations. The course will focus on the techniques of design of foundations, so it does not fail during the earthquakes. This will cover both shallow and deep foundations, and major focus on this course will be on the design of deep foundations for lateral loads. The course has been divided into 5 modules. The first module M1 is introduction, which we are going to cover today, and then second one is on the shallow foundations, third module is on pile foundations, and fourth one on well foundations. The last, that is the 5th module of the course, will be on a special topic which is related to soil structure instruction for deep foundations. So, let us discuss that what are in these different modules. Introduction is going to cover objective of a foundation, what are the major issues during earthquakes, and how is the performance of foundations during the past earthquakes. This will be covered today. In the second module, which is on shallow foundations, there are 5 chapters. The first one will be on general requirements. The second chapter will talk about bearing capacity and settlement. Third one will be on combined footings. Fourth on raft foundations, and final 5th chapter is on dynamic bearing capacity. All these will be studied in detail. In the third module, which is on pile foundations, we will talk first about what types of piles, then laterally loaded piles, which is very important during the earthquakes, and finally how to carry out the analysis of pile foundations using softwares. So, to know that about that, we need to understand discrete and finite element idealization of pile foundations. The fourth module of this course will be on the well foundations, where the first chapter will talk about types, scour depth, bearing capacity. Then we will discuss the lateral stability of wells, pseudostatic analysis, and Indian Road Congress methods for lateral loads for well foundations. In the fifth module, which is on SSI for deep foundations, first there will be basic introduction on soil stress interaction. Then we are going to discuss that how to model unbounded soil media. It will be followed by free field motion, kinematic interaction, and inertial interaction. Finally, we are going to talk about soil pile interaction, which is very important for pile foundations. These are the list of the references which will be very useful for this course. The first reference is the book by Professor Shamsher Prakash on soil dynamics. This was the first book worldwide on this topic, and it covers about dynamic soil properties as well as some of the important issues like liquefaction, pile foundations, machine foundations also. Then the second book, which is very famous, by Stephen Kramer, published originally in 1996, is on geotechnical earthquake engineering. This will give the basic background on the dynamic soil properties, liquefaction, and ground response analysis. Then the third one, which is by Bowles, is very practical book with numerical examples on foundation analysis and design, though most of the things in this book are covered on a static part, but it will cover on well foundations as well as raft foundations has been given good. Then a publication by Professor Murthy on advanced foundation engineering will be also helpful. Last two, the fifth one, which is a book on basic and applied soil mechanics by Ranjan and Rao, though this publication, fifth publication, is mostly covered in at undergraduate level, but some of the advanced things in this book given will be helpful for this course. Finally, the book by Professor Swamisaran is on soil dynamics and machine foundations. It is basically an update on the first publication by Professor Shamsher Prakash. So, these references would be enough for this course. Now, let us have come to the module 1, which is an introduction of this course, and as mentioned, first thing is there are three components of this module. First is objective of a foundations, then what are the major issues during earthquakes, and we are going to discuss how the foundations perform during past earthquakes. When we know that foundation, the earth provides the ultimate support to the structures, because ultimately whatever structures, whatever buildings, roads, bridges, all the loads need to be transferred to the ground, that is on the earth, and foundations are nothing but they are the substructural elements which transmit the structure load to the earth in such a way that the supporting soil is not overstressed. That is, we in technical terms say that bearing capacity of the soil should not be exceeded, as well as the second criteria that it does not, soil should not undergo deformation that would cause excessive settlement of the structure. So, that means basically the settlement should be within the permissible limits. So, this is the basic objective of a foundation, transferring the load to the ground from the structures. Now, what are the major issues which come up during the earthquakes, which is different when you do not have the earthquake loading. When you have the normal loading, those issues may not be the problematic, but during the earthquake there are some special issues which we need to focus for foundation design, and let us talk about that. During the earthquakes, the foundations and surrounding soils are subjected to the time varying dynamic loads, and its behavior is very different than during the static loads. And what is the reason for behind that? First of all, during the earthquake, particularly when there is a strong shaking, the behavior of soil is normally nonlinear. So, that means we need to consider the nonlinear properties of the soil in the analysis. Then there could be excessive large settlement, particularly if your soil is liquefiable, then settlements are very excessive. And if the foundation is on loose saturated cohesionless soils, then there may be possibility of liquefaction, which also need to be accounted. So, while dealing with the earthquakes, we need to take into account all these issues. It is important to know that how the foundations have performed during the past earthquakes, because that will give us the feedback that what are the problems and how we can deal with those problems. During the past earthquakes, there are a number of examples in which foundation damaged caused collapse of buildings, bridges, dams and many other structures. And as an alternative, or as a to avoid the damage of the foundations, deep foundations were considered one of the most effective means of mitigating foundation movement during an earthquake, and these issues we are going to discuss in the next of the few slides. So, you may be aware that in 1964, that means now almost 55 years before, there was a major earthquake in Japan called Niigata earthquake with a magnitude 7.5, and it resulted in very much damage due to liquefaction. And at that time the Niigata city was very not large. At the time of earthquake, there were approximately 1500 reinforced concrete buildings in Niigata city, and about 310 of these buildings were get damaged due to earthquake. Out of these damaged buildings of about 300, about 200 buildings settled or tilted in such a way that there was no damage to the superstructures, and this can be seen in the next slide. So, if you see that this building which has fall down have got, there was no damage to the superstructure. However, the foundation of this building get failed, and the foundation has failed due to the liquefaction induced bearing capacity failure. But this building got failed, this get tilted, this is also get tilted while others are standing. So, the reason for this was observed that those buildings which were on shallow foundations or on friction piles on loose soils got damaged. Similar buildings which was on pile bearings on firm strata at a depth of 20 meter did not suffer damage. So, this is an example which suggests that if we use the pile foundations, that is the performance of the buildings are going to be better during the earthquakes. So, this is the field evidence from Niigata earthquake. This slide is also from the Niigata earthquake, and this building got settled as well as tilted due to liquefaction induced settlement. this is an apartment building in Niigata earthquake. So, you could see that building is standing, though it gets settled as well as tilted, and this was the result of the foundation failure during this earthquake, and this building could collapse at any time. Then let us see the example of the foundation of the bridges. This slide is also from Niigata earthquake, and the bridge got damaged due to lateral spreading. Lateral spreading is a phenomena which is related to liquefaction, and you may be aware that during the liquefaction, due to shaking of earthquakes, there is an increase in pore water pressure. As a result, soil lose its shear strength. So, due to the earthquake there is liquefaction, and due to liquefaction there is a lateral spreading, and the lateral spreading has caused damage to this bridge. What happens that bridge pier foundation moved and rotates in such a way that the simply supported span fall. So, ultimately you can say this bridge get collapsed. So, that is why this is another example suggesting it is very important whether you design a building or whether you design a bridge, then you need to design the foundations so that they are safe during the earthquakes. Then another example for damage to the bridge due to lateral spreading, this is from 1952 Tokachi Oki earthquake, which was with a magnitude 8.1 in Japan, and again in this case also the abutment of the bridge get buckled due to the lateral spreading of the soil. So, this is this abutment got damaged. As a result, when this abutment got collapsed, then the deck of the bridge have come down. So, this is also liquefaction induced failure of the foundation. In the next slide, it is from Kobe earthquake of 1995 from Japan, which was with a magnitude of 6.9, and this is an oil storage tank. You could see this on this tank is founded on the pile foundations, and the soil below this tank get liquefied. However, there was no damage to the tank, and the reason being because this tank was situated on pile foundations and piles was passing through the liquefiable soils, but resting on the hard strata. So, later investigations has pointed out that there was some small damage, like we could see in this figure on the piles, but there was no damage at all to the tank. So, this example suggests that if we use proper foundation or if we design this foundation properly for earthquake loads, then our buildings, our superstructures, bridges can be survived and they may be safe. So, it is very important. Now, coming to the next example, which is also from Kobe earthquake, you could see this bridge which is called Higashi Nada Viaduct. It completely collapsed, and this is also live example of foundation failure in 1995 Kobe earthquake. Here it appears that the piers as well as the deck of this bridge was constructed earthquake resistant design, but the foundation get failed, and you could see that this reinforcement of the piers is coming out. So, it is completely collapsed. So, again reminding us that it is important that we design earthquake resistant design foundations. This example is also from 1995 Kobe earthquake of magnitude 6.9. so here Nishinomiya bridge approach span get collapsed, and this was result of lateral spreading on the ground due to the liquefaction failure. You could see that there are fissures, there are like the cavities on the ground, and these are due to the liquefaction result. When the liquefaction occurred, the foundation get failed, and once foundation get failed, the bridge got damaged. Continue with this. This is another example from 1999 Chi-Chi Taiwan earthquake of magnitude 7.6, and you can see that this is a bridge or flyover, and the piers of the bridge got damaged. There is a peculiar damage to this pier, and this is also resulting from the foundation failure below. So, once there is a the foundation get failed, as a result you could see that there are damage to the piers also, and ultimately this made this bridge unfunctional and it cannot be used anymore. So, this was from Taiwan. Then we do have some examples from our country. When we talk about our country, you may be aware that 2001 Bhuj earthquake is very notorious. This occurred on 26 January 2001, that was a Republic Day, with a magnitude of 7.7, and there was lot of damage in Gujarat, Bhuj area during this earthquake. This is one of the example where there was a damage to pier cap of bridge, and all these damage are related to the foundations failure. So, this was not simply that this is pier cap has got damaged, rather like this is below this, because ultimately this bridge will transfer the load to this pier, and pier will be transferring to the through the foundation to the soil. Then another example from the Bhuj earthquake, where this is Rudra Matha bridge, and this was the status after 2001 Bhuj earthquake. So, in this bridge you can see that this is intact and this was fully functional. So, there was no damage to the bridge as such, but let us investigate its foundation. So, if you could see that this is the piers, and ultimately this is transferring the load at this place. Let us zoom this section and see in the next slide this part. And if you see in this slide that this is well question here, there is a well here, and there is a lateral spreading. This is lateral spreading which is occurring here, it is due to the liquefaction induced lateral spreading, because the soil here got liquefied, as a result there are spreading here. These spreading try to that subsidize this well foundation, but the well foundation was properly designed and it could easily it could survive. As a result, there was no damage to the foundation, and the bridge as seen in the last could be in the last slide is intact, and it was fully operational and functional. Now, this slide is from Kerala, a place called Kilamanakudi. In fact, there are two villages in that Kilamanakudi and Milamanakudi, and this bridge was connecting. So, one is on this another side and on the another end, and the bridge was connecting two villages. This slide, this photograph is taken by ourselves during the 2004 Sumatra earthquake. In January in 2005, after the Sumatra earthquake, which caused lot of tsunamis, and you may be aware that in 2004 Sumatra earthquake in South India, there was not damage due to the earthquake, but damage was due to tsunami, but the reason of tsunami was earthquake itself. So, due to the 9 magnitude Sumatra earthquake, there was tsunamis, and tsunamis caused damage, and this was photograph is showing this. There are 4 span of the bridge, and you could see there was not even a single span, all have washed out. And interestingly, this bridge was newly constructed at the time, it was not even 1 year old at that time when we visited in January 2005. One of the span have moved about 20 meter away, and this you could see this is lying here. Then if you see, the force of the water due to tsunami was so high that another span is inside this sea, and then you could see the bare, the only this these are the piers, and then pier caps can be seen only, there is no deck. So, there is no movement. We examined this, the reason of this collapse of the deck, and we found that there was separation of this span from the bearings here. So, it could be said it was say the bearing failures of this bridge lead to the collapse of the span. So, these were the few of the examples from the past earthquake, where you could see that some of the cases are suggesting that there was no problem, because foundations was properly designed, foundation was have concept of earthquake resistant design, but then there are some examples which suggested that if foundation is not properly designed, then there may be damage or even collapse during the earthquakes. So, it is very important to have earthquake resistant design of foundations, and that is our mandate for this course, and we will continue this course in the next lecture with on the second module, which is on shallow foundations. Thank you very much for your kind attention.